So these were the notes we did in the second part of class, which went considerably faster than the annuity and lump sum stuff that we did. So I would expect they would go faster here as well. So at the top of the page, we have several exponential equations, some of which we could do just off the top of our head, some of which we might have to do some work for. So I'm asking for the value of x in each of these. So 2 to the x equals 8. Obviously, x would be 3 because 2 to the third is 8. And then 4 to the x equals 1/16. If you remember your exponent rules, that 1 over a number means a negative exponent. So this is like 16 to the negative first. So 16 to the negative first is like 4 squared to the negative first. So that's 4 to the negative 2. So 4 to the x equals 4 to the negative 2. X equals negative 2. Now, the third one, when you say that something to a power is 1, that power is pretty much always 0, right? Because anything to the 0 power is 1. Now, the ones at the bottom require a little more work, but it's not bad. We talked about rewriting the bases as powers of the same number. 8 is 2 to the third. 16 is 2 to the fourth. And when you raise an exponent to an exponent, you multiply them. Now you have the equivalence of exponentials, and you can solve for x. So 8 to the 4/3 power is 16. So pause the video and do the last two in the way that I just did these, and I'll give you the answers when you unpause. All right, so the answer on this one is 2/3, and the answer on this one is negative 3/5. Now, in each of those problems above, we were asked to find an exponent. Now, there's actually a mathematical operation that does that, that asks to find an exponent, and it's called a logarithm. So the way a logarithm works, and I'm going to first of all just sort of show you what the notation looks like. If I wrote log, that tells me I'm working with a logarithm, and then there's a little subscripted number next to that. We'll call it 2 at this point. That's called the base. And then there's a number like on the same level as the log, sometimes in parentheses, sometimes not. That number is called the argument. Now, what does this mean? Well, if you look at the paragraph below, a log always asks the same question. To what power do I have to raise the base in order to get the argument? So in this case, to what power do I raise 2 to get 8? Well, that's right. It's the third. We talked about that at the very beginning, right? So in this case, log base 2 of 8 is 3 because 2 to the third is 8. Now these two things, that log and that exponential that I just wrote, are equivalent statements, and we're going to come back to that in a minute. So if we look at these questions at the bottom, these are all asking, what power do I have to raise the base to get the exponent? So 2 has to be raised to the third to get 8, so log base 2 of 8 is 3. 4 has to be raised to the negative second to get 1/16, so log base 4 of 1/16 is negative 2. And you can keep doing that by looking at the problems above, because that's why we did the problems above, to fill out the values of these other logs. So remember, whenever you're finding a log, essentially it's asking to what power do you raise the base to get the exponent. Now, let's look at in this little box here, where I wrote that log as the exponential, and I'm going to do that just because this log gives me an exponent. We often call the thing on the other side of the log equation an exponent page. Now, I'm going to take what I did, the general log. So if I have log base b of x, and I say that equals I, that's asking to what power do I raise b? Oh, by the way, now, this says to what power do I raise b, and the exponent is what the log equals to get x. So these two things are, again, like I said before, equivalent statements. It's kind of like when we had linear equations, we could write them in different forms. These are two different forms of the same equation. This is called logarithmic form. This is called exponential form. So you're going to have to be comfortable moving back and forth between the forms, so you'll get some practice in doing that a little bit later. So we're going to look at these logs below, and we're going to evaluate them by hand. So this one says, to what power did I raise 3 to get 81? Well, 3 times 3 times 3 times 3 is 81, so it's 3 to the 4th. And that's true because 3 to the 4th equals 81. Log base 4 of 1, well, anything to the 0 power is 1, so log base 4 of 1 is 0. And again, that's true because 4 to the 0 is 1. Now, when you get to log base 100 of 10, you may have a harder time thinking about that. So whenever you're looking at a log and having to evaluate it by hand, and you are unsure what the value is just by looking at it, here's a little trick. You can take the log and say, hey, I don't know what it is, so I'm going to set it equal to a variable. And then I can take that thing, which is in logarithmic form, and rewrite it in exponential form. So the base of my log becomes the base of my exponential. The log equals an exponent, so that becomes my exponent, and it's supposed to give me what's inside the argument. Now, when you do that, you end up getting equations just like we solved at the top of the first page, where you can rewrite the bases as powers of the same number, use your exponent rules to simplify that, use the equivalence of exponentials, and solve for x. So I'm going to do one more of these with you. I'll do this one that's here in the middle. Rewrite it as a power, rewrite it as an exponential, so my base becomes the base, the log is the exponent, and it gives me the argument inside. I can then rewrite these bases as powers of the same number, use my exponent rules, equivalence of exponentials, solve for x. So pause the video and do the last two problems on your own, and I'll give you the answers when you come back. Cool. So log base 27 of 3 is 1/3, and again, that's because 27 to the 1/3 is 3. Log base 32 of 16 is 4/5, and again, that's because 32 to the 4/5 power is 16. Now, the thing at the bottom, we didn't actually cover in class. We're going to talk about that at a later date. You can read over it if you'd like, but just notice that there's a button on your calculator that takes logs, but it is a specific kind of log. It's not a log with any base. So we'll talk about how to deal with those things later, but for now, that's it for these notes.